Have you ever wondered what exactly is a spark or a spark of lightning? Or have you questioned yourself what happens inside a spark plug? Or how a spark is produced in a charging socket? Or how lightning occurs? If curious, then stay with us.
Do you know what is lightning? Lightning is a naturally occurring phenomena of electrostatic discharge during which a tremendous amount of energy as much as 1 gigajoule is released. To begin, let's understand the concept of ionization. When a neutral molecule or an atom gains or loses an electron, it becomes an ion, and this process is known as ionization. For lightning to occur, there must be both cold and warm air. The water from the Earth's surface gets vaporized and then condenses to form clouds. These clouds have turbulent cold air within them, which contains the ice crystals. The hot air in the atmosphere, which contains water droplets within them, moves upwards due to its low density. Now what happens is, the droplets in the hot air collide with the ice crystals in the cold air, resulting in the production of static electric charges. Now, these negative ions settle on the bottom of the cloud, whereas the positive charges form the upper part of the cloud. This is known as the colliding theory.
So the other theory suggests that the vapor first undergoes freezing at high altitudes, and this is known as the freezing process. The frozen particles start freezing from the center of the droplets. The droplets attain positive charge due to this, and the frozen particle attains a negative charge. The droplets are carried by the turbulent air which constantly flows in the cloud. The turbulent air carries this droplet at the top of the cloud, making it positive, while the frozen particles gravitate at the bottom, making it negative. While the charges separate is still a topic of active research. A belt of positive charges builds up on the ground beneath the cloud around sharp objects. This positive charge interacts with the negative charge of the cloud, and thus a spark of lightning strikes. A single bolt of lightning can ionize the gas around it up to a temperature of 30,000 degrees Celsius, which is about 5 to 6 times hotter than the surface of the sun. Well, this causes the massive expansion of air due to increased temperature and increased pressure, thus producing a sonic boom of sound known as thunder. You might have noticed that we hear thunder after lightning. Well, that's because light travels 10 lakh times faster than the speed of sound.
Similarly, in a spark plug, the gases between the center electrode and the ground electrode gets ionized, resulting in a spark. In an adapter, due to electrostatic attraction, the positive charge density at the tip of it increases, which is commonly known as action of points. This results in the ionization of the gas between the adapter and the charging socket, and thus a spark is produced. Same goes for lightning arresters, which are used for safety purposes in skyscrapers.
During a thunderstorm, try to stay indoors. If outside, try to stay inside the car. Well, this is because according to Gauss law, the electric field inside a conductor is zero, making it a region of constant potential. So most of the current passes through the outer surface of the car to the ground, making it an electrostatic shield, also known as Faraday's cage. Even try to stay away from sharp objects like trees or branches of trees or even people because they concentrate high positive charges.
If lucky enough, even water might save you from lightning strikes. Now this is something tricky, isn't it? Water, being a good conductor, discharges most of the electricity to the ground, thus acting as an electrostatic shield.
Let us see some interesting facts. Color of lightning is most often white, but sometimes we might even see other colors tingling around the edge of the lightning. Well, that's because as the temperature increases, the color reaches at the end of the spectrum.
According to a report from National Geographic, around 2,000 people get killed each year by lightning strikes.
Each strike of lightning can release an energy of about 5 gigajoules, which is approximately equal to burning 145 liters of gasoline.
Each lightning strike can contain up to 1 billion volts of electricity.
Lightning strikes about 50 to 100 times each second worldwide.